So what I need you to do is to get out a piece of paper that says Day 4 Quadratic Functions, Quadratic Formula on it. And we're going to take that problem on the back and look at some calculator practice. So at the top, above number 13, it says suppose h of t equals negative 5t squared plus 10t plus 3 is an expression giving the height of a diver above the water in meters, t seconds after the diver leaves the springboard. So the first question says, how high above the water is the springboard? Explain how you know. So as we're going to y equals, and keying in the negative 5x squared, x for t, plus 10x plus 3. As we discussed yesterday briefly, this equation is in standard form. So this last number, that constant value, is always the y-intercept. So in terms of a word problem, that is always the starting height, or the initial value, the starting position, if you will. But let's go ahead and look at a graph. I want to go to my standard window just to see what we can see. And there's the graph of that diver jumping off the springboard. Now when you hit trace, your cursor, your blinker automatically goes to that y-intercept as that first point. So you can see that as x is 0, so that, remember, x is taking the place of t, which is time. So at time 0, or the initial time, the starting time, the height, the y value is 3. So that's another way you can see that 3 meters. Also, if you go to your table, you can see here the initial time at time 0, the height is 3 meters. So there are 3 ways that you can pick out that initial height or that starting position. If you're talking about, for instance, money or population, that's going to be your starting value. The next question, when does the diver hit the water? So that's going to be when the height is 0, or that's going to be when the diver leaves the springboard and then comes back down. This point right here, this x-intercept, is the point where the diver hits the water. Again, that's the height of 0. Now, you could find that by hand using the quadratic formula or completing the square. It's not going to factor this particular problem. But to find that value, we can go to Second Calc, and we can choose 0. That's letting you find an x-intercept. Then you'll be asked to move your blinker left-bound. That means you want to be on the left side of that x-intercept. So anywhere on the left will be fine. Then you can click Enter. Right-bound means you want to get to the right side of that value. Hit Enter. And you'll notice, as you have guessed, your calculator will put 2 little triangles pointing toward each other, and that x-intercept that you're looking for needs to be in between those 2 arrows. So you see the word guess. That's your clue to hit Enter one more time. And that 0, that x-intercept, then is 2.26. So at 2.26 seconds, that diver is hitting the water. Now, I also know some teachers will tell their students, if you're trying to find the x-intercept, to go in to y2 and put 0 right there for that y value. When you hit graph, the graph will, depending on the version of your calculator, it may or may not look any different. If you have an older calculator, an older TI-84, you won't see any change because your calculator is just putting a horizontal line on top of the x-axis, so you won't see any change. But if you have a newer calculator, a color edition, you'll see a line come across that x-axis. So since you technically have 2 equations in your calculator, you've got an equation in y1 and an equation in y2, you can use this intersect feature. So if you choose 5 for intersect, then move your blinker so that it's close to that point of intersection or that x-intercept that you're looking for. You can hit enter 3 times and get that same value, that 2.26 seconds. So that's 2 different ways you can find your x-intercept, either using the Calc 0 feature if you just have in that one equation, or if you want to put in y equals 0 into y equals, then you can use the Calc intersect feature. It does not matter to me which method you choose, as long as you can consistently use one of those methods. And by the way, we don't look at this x-intercept over here because that will be a negative time, and in the real world we typically don't deal with negative times. The next question says, at what time on the diver's descent toward the water is the diver again at the same height as the springboard? In other words, the diver started at 3 meters, So as the diver goes up and comes back down, again, where is that diver at 3 feet? Sometimes we're fortunate enough to see those values in your table. 3 meters, I keep saying feet. So that's the initial height of 3 meters. And you can see then again in your table, there's another 3 in the Y column. So that's the point where they're coming back down and hitting that 3 meter height, and that's happening at 2 seconds. Now, if that value doesn't show up in your table, you can do what we've done previously and put a y value of 3 into y equals. And then when you look at your graph, the first graph will be your parabola, the path of the diver, and then there is your height at 3 meters. So you can find that value again by determining where those two graphs intersect. So second calc, intersect, and then if you hit enter 3 times now, you're finding that initial height, but we don't care about that. We already know that. We want to know, when does the diver hit 3 meters coming back down on the other side? So you'll have to move your blinker to the other side, close to that point of intersection, and then hitting enter 3 times will give you that value of 2 seconds. So again, at 2 seconds, that diver is on her way down, and she passes through that height of 3 meters again. And then lastly, number 16, when does the diver reach the peak of the dive? How high is the diver when she is at her peak? So that's another way of asking you for the vertex, that maximum value. And in a lot of your real world problems, you're looking for a max and not a min, because if something is launched, it's going to come back down. So if we go again to second trace for calc and choose number 4 for max, again, we just have to have our blinker to the left of the max, and when it's there, we hit enter. Then we're asked for right bound, so we have to move our blinker to the right hand side of the max, and when it's over there, we hit enter again, and then guess, that's your clue to hit enter one more time. And our maximum is, I'm showing 0.9999978. Your calculator might show you 1.8 exactly, or might say 1.000 something 8. But as we talked about yesterday, you need to make sure that you understand that this is just your calculator's way of giving you a value of 1. So the vertex is the 0.18. So that means at 1 second, that diver is 8 meters above the water. So now, as you begin working on some modeling or some word problems as you encounter them, you can let your calculator help you find some of those values.